So this is called the work kinetic energy theorem. And we basically said that the total amount of work done on a system is equals to a half its mass times its final velocity minus a half its mass times its initial velocity squared. So this would apply, say, let's say this was our resultant force and the object was displaced some sort of distance delta x. Sorry, I'll just do it like that. Here it had some velocity vi. By the time it arrives over here, it has a velocity v final. And let's just for now assume that this resultant force is constant. So it doesn't change in magnitude or direction. Now we can rewrite this then in terms of what we did just with straight line motion. We can say, well, this block will have some constant acceleration because we know F res is just equals to mass times acceleration. It will have an initial velocity over there. Over here it will have a final velocity after moving a distance delta x. So if I recast this as a constant acceleration problem along a straight line, and I asked you, well, how can I relate all of these quantities in a single equation? You know we've got this equation v final squared is equals to v initial squared plus 2 times acceleration times delta x. So we can write this as a times delta x is equals to a half v final squared minus a half v initial squared. Right, we just rearrange terms. If I multiply with the mass of the object, I get the mass of the object times the acceleration times the displacement is equals to a half m v final squared minus a half m v initial squared. This is just the resultant force dot with the displacement, and it is equals to a half mv squared final minus a half mv initial squared. So we have that, we've got two different theories. We have one, if we've got constant acceleration, and we've now had this idea of work. And we said, okay, work must change the energy, so let's see if we apply a force, what is the quantity that's changing for any general force that can be possibly non-constant. And we found, well, if the only effect that this force can have is to change the velocity of the object, so the object cannot deform, it cannot break, cannot heat up. We found from just from definition of work that this is what is changed. So this quantity half mv squared is the quantity that is changing as we apply work. And so we decided to call that an energy, in this case kinetic energy. For the very special case where the force is constant applying the direction of motion, from our equations of motion we get the same thing. So it tells me that the way we define work and the way we interpret it is we're on the right track.